Okay, so chapter 3, we're going to start talking about random variables and probability distributions. Well, we're going to start talking about them. We're not going to finish them in just in chapter 3, but that's where we're going to start. Random variable. Okay, this is just a function that assigns probability to each element of the sample space. In other words, for every possible outcome, it will assign a probability for it. And now there's a variety of different ways we can go about this. You could have, for instance, a uniform distribution. That's just, here, pick a random number between 0 and 1. And they're all perfectly, just 100%. They can be anywhere. And there's no rhyme or reason. The probability is 100% just spread out all across here. And they all have equally likely chance of happening. Okay? It could be something that looks like this. We'll talk more about this later on, but the normal distribution. Well, that's a disgusting version of it, sorry. Oh my gosh, it's like the bell curve, Jay. Exactly, it's exactly what that is. Okay, clearly it's not weird to see a gal somewhere between 5'4" and 5'6". That's pretty darn common. You start talking about 4'11", that's pretty weird. It stands out. That doesn't happen all day, every day. Get a gal that's about 6'3", that's a little strange too. You don't see that very often. So weird. So no, the data is not uniform this time. There's a big pile of it in the middle. And we can talk about how spread out it is. We can do all manner of different things. Okay. We're going to talk about a couple of different kinds. We're going to talk about continuous distributions, where any number is allowed between wherever and wherever. So for instance, height, any number technically is allowed from negative infinity to infinity, technically speaking. Of course, the tallest man ever lived was 8 foot something, supposedly. I think that was what the actual number is in the Guinness book. And the shortest, adult male, probably, a couple feet tall or something. However, that's not to say that you couldn't go a little bigger or a little smaller, but a little smaller, it would have to end at 0. Well, technically, it could be 0 probability of it happening less than 0, less than or equal to 0. It could be a 0 chance of it happening less than or equal to 1 inch, or whatever it happens to be. In other words, you could define it over the entire realm. It would just have to be such that between a certain value and a certain value, that's where all your 100 ends up. So anything outside of those bounds could be 0. So we can do continuous distribution. We'll also talk about discrete distribution. For instance, the number of male puppies in a litter. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I guess. Pretty odd Pretty odd that a dog would ever have more than 10 puppies. So clear, and it would be very weird to have all 10 of them be boys, right? But it's not impossible. But let's just say she had 10 puppies, then somewhere between 0 and 10 is the number of boy dogs she could have out of that bunch. Okay? That is, they come in whole number amounts. How many potholes in the road? 2. How many TVs do you own? 3. How many cars? 0. How many this? 5. 1, 2. Discrete distributions must come in whole number, discrete amounts. In other words, it's not possible to sell 2.5 tacos today at the taco store. It doesn't work that way. Okay, now there's a variety of them that we have. And so, again, this is all numbers, or if you will, there's an infinite number of outcomes. This is a discrete number of outcomes. They come in packages. There's only a certain number of them in there. What I would like you to think about is this, though. The sum on this guy down here, the sum, of the f of, and your book uses f of t, I believe, where t goes from, let's say, 1 to n is equal to 1. That is, the sum of the probabilities has to have to 100%. This is the t sub i's, I guess. There we go. Okay, and the idea being is, so I should say I should go from 1 to, there you go, I goes from 1 to. The idea being is that there's a multiple of outcomes, but if you add up all the probabilities of all the outcomes, it better equal 100%. How is that different than this one up here? Well, this one up here is a continuous function. Well, wait a minute now. What are you saying, Jay? Are you saying that the area under the curve? That's right, the area under the curve from A to B better equal 1 for that to be a probability distribution. Okay, so down here, again, you add them all up. That's great. Obviously, up here, there's an infinite number of them, but if you integrate from A to B, the area under that curve better be 1. Okay? It's pretty straightforward kind of a deal. Don't overthink it too much. For instance, a nice discrete one is numbers on a dice. So you get a 2, 3. This is out of 4. This is out of 2 dice. There's one way to do this, and there's one way to do that. Double ones, double sixes. Get a 1 and a 2, or 2 and a 1, 5 and a 6, 6 and a 5. A 1 and a 3, a 2 and a 2, a 3 and a 1. 5 is 3 and 2, 2 and 3, 4 and 1, 1 and 4. 6, 3 and 3, 5 and 1, 1 and 5, 2 and 4, 4 and 2. And then 7 is 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. There are 36 total outcomes. Each one of them has this probability of happening. If someone said to you, hey, what's the probability that I get a 7? It's 6 out of 36. It's probably I get 11. Not good. It's 2 out of 36. And so on, and so on, and so on. Okay? If you add those up, they better equal 1. If it equaled 0.999, well, you screwed up somewhere, pal. And you missed one of them. It has to add up to 100% or 1. Okay? In 3.1 and 3.2, it's just pretty much introducing the concept. Not a very difficult concept at all. It's just, it's a nice and easy one. If someone said to you, listen, I've got this function, this continuous function, and it goes from 0 to 2, and I'm just going to make up that function here. I'm going to pause you for 1 moment, please. Okay, so there it is. And yeah, so it's just this equation here, and it kind of just continues on. But I'm going to look at it from the bounds from 0 to 2. So what I want to ask you is this: is this a probability distribution? Let's find out. If it is, this thing better integrate to 1 over the interval in question. So this would be negative x cubed over 3 plus 2x squared. So that's negative 8/3 plus 8, which is 24 16/3. It's a little big. What if I told you you had to multiply it by 3/16? If I told you that, then your answer would be multiplied by 3/16, and the answer would come out to be 1, which is pretty slick. So if someone asked you, hey, is this a PDF? You would say it most certainly is, because it integrates to 1 over that region. Now, obviously, you cannot just make this crap up. You're like, I'm just going to make one up. No, it doesn't work that way. But what you need to realize is that's what they add up to. We will see this one. It shows up a lot in our walk. You'll see a lot of these ones. E to the negative x from 0 to infinity. Is this a PDF? Let's find out. So if you do that, you're going to get negative e to the negative x from 0 to infinity. I'll do the hard part. So obviously at 0, the answer is 1, so that's a minus 1 on the bottom end. And then what happens at infinity? Well, e to the negative x is another way of saying that is 1 over e to the x. And what happens to this as x goes to infinity? The limit, we say, the limit is approaching 0. So ta-da, equals 1. Check. Nice. And so it'll be a very interesting problem. We'll look at that some more in class this week. But that's the game. You'll be asked to find stuff. This E1 shows up all the time. This is what's called an exponential distribution. We'll look at some other ones as well as we're going along. This week in class, we're going to do some more examples. We'll talk about that a little bit. And we'll talk about joints later on this week. Or next week, rather. Joint distributions. Okay. Now say I asked you to make up your own PDF. Can it be anything, Jay? Yes and no. 2x plus 1 clearly could work. See that? And so the idea here is that this thing needs to integrate to 1 over some region. Now, the easy way to do it if you're making one of these up on your own is to do this number, I suppose. So it's going to be x squared plus x from 0 to a, and it has to equal 1. Well, that's a squared plus a, and of course minus 0 is equal to 1. And then a guy can solve this and see what happens here. Okay. And if you're weird, like you're bored because there's a coronavirus on, and you're like, I'm gonna do this by hand. Go for it. What are you doing? There you go. That's your answer, baby. About 0.618. So in this region in here, we'd be there, we'd be home free. Okay? That makes sense. Now you're like, well, what about the other answer there? The other answer would have been a negative number, and the negative number isn't going to cut it. Think about why that would be. If you had a or x equal to a negative number, that would mean your x would be negative. It would be negative in here, more than likely, and so we have to be a little bit careful there. Okay, so let's see if this works. Let's actually do the math on that a little bit there. So if I take the integral, oops. There you go. With accounting for rounding, we were done. Okay. Could we have gone the other direction here? Let's find out. Just for fun, what does this other one even? What does that other one even mean? Let's find out. Negative 1.618. We have a bit of a problem there, friend. So, something's, oh, because this thing's out in front of it there. I'm an idiot. Let's try it again. Hippie. Okay. Hey, it's 1. Okay, now why is it negative 1? It's negative 1 because I went from negative 1.61 up to 0. In fact, I put the a on top in the original problem, meaning that this would have to go from 0 to negative 1.618, which makes no sense because you'd be integrating right to left, which is backwards. Okay, so obviously the negative 1.618 is an extraneous root. We're not going to worry about it. Okay. Something else that bothers me about that negative 1.18 is kind of weird. Let me show you why. Negative 1.618 is over in here somewhere. So we're talking about these are negative probabilities. Everywhere on this line is a positive probability. So the lowest we can ever go, negative a half, whatever that means for x. That's the lowest we could ever go that would make sense to us because remember the blue, the y value of that blue line is the probability of any given part of the function. So just keep that in mind. So if I give you an x, let's say x equals 2, you plug it in, that function will tell you what is the probability of that happening. Okay. Nice. So that's the game on section 3.2. We're going to do some more with this next week in class, or later this week, next week I should say, in class. So just be aware, be heads up on that deal. Next week, in the video conferencing, what I'm going to talk about this next week is we're going to discuss some more of this idea a little bit, do some more examples, and then we're going to come into the idea of a joint distribution. Okay, so you'll see what I mean by that when we get there.